Good morning, everybody. Good afternoon. Thanks for coming on a few minutes early. My name is Marie Ashway. I'm here with Mainline and with Andy Hartman. We're going to get started here in just a few minutes. So we were just getting ourselves kind of set up and sort of talking about different things. And one of the topics that came up was AI and ChatGPT and things of that nature. And we were kind of talking about everything from how, at least I as a marketer have found that that has been an amazing tool to help me. Sometimes we have writer's block and you can't get over a certain sentence, or you're having trouble with a paragraph, or hey, make this better for me, to the whole issue that it brings now upon education and school systems, and how do you get students to do the work and not go running home and doing their homework using ChatGPT, right? So we were kind of talking about this whole impacts of all of that, and then I said, I wonder if you could ask ChatGPT to give you a recipe for chicken thighs. And I laughed, but I tried it and came up with a lovely recipe with lemon slices and everything. So if you haven't learned anything today, or don't learn anything today, although I'm sure you will know that you can go to ChatGPT to get a recipe for chicken thighs.
That's what's on the menu at Marie's house for dinner tonight.
There you go. So anyways, we're just waiting for the top of the hour here. Thank you all for coming on a few minutes early. I appreciate that. And at any time too, use your chat window and feel free to chat me up or chat Andy up or any of us that are here. Would love to know your thoughts on some of these things as well. So feel free to chat us up here.
Yeah, Marie, let me know if there's any questions I need to answer in the chat box. I can't see it right now, but.
Of course. Yeah, I will let you know for sure, Andy. Thanks.
Yeah.
All right, another minute or so here. We're going to get started. So for those of you that are on here a minute or so early, I'll let you in on a little secret, kind of an odd space that I'm in. You might wonder, that's kind of an odd space that she's in. I'm on a boat. So my husband and I live on board a boat for the summer months, and we do this every year, and we've been doing it for years. So yeah, odd space. So my little secret to you today is that I'm coming to you from the Katy. That's the name of the boat. She's named the Katy, which was my mother's name. And that's where we're broadcasting from. So, little secret. All right, it's the top of the hour, and so we are going to get rolling here. So again, my name is Marie Ashway. I'm with Mainline and happy to host today. And with me is Andy Hartman. Andy is a senior systems engineer here at Mainline, focusing primarily on the Z technology space. Andy has 30 plus years of mainframe and mid-range environments. He joined Mainline in 2001. So Andy, you have 23 years this year, which is just outstanding. Outstanding. He does a lot in systems design and performance analysis, capacity planning, and that type of thing, mostly for new workloads on IBM Z. So that's going to be our speaker. But before I bring Andy on to actually start, I want to make sure that I run through some logistical things that I need to say. Number one, this is being recorded. If you have any objection to being on a webinar that's being recorded, we do use this for replay purposes. Now would be your time to leave, although I certainly hope that you will stay. And you'll notice that you're muted. So the best way to communicate with us is going to be through your chat window. So please use that throughout the course of today's session. And I'm going to do a few polls here with you in just a minute. So you'll get to do a little polling with me. And then at the end, when this is over, there'll be a quick survey. It's like 1 or 2 questions. If you would please answer those, I would really greatly appreciate that. So let's see, can we get a copy of the recording to show to other team members? Thanks, Eric, for asking that. Yes, this will be posted on our replay site on mainline.com, and I will chat that replay site out to you in the chat window here in just a minute. Yes, these are all recorded and are available. And you are welcome, Eric. Thanks for that question. All right, so let's do this. Let's get to know a little bit about you all. I told you where I was. I'm on a boat. So I want to know, where are you located? And I did say today, because people move around a lot. Where are you located today? East or west of the Mississippi? In a U.S. territory like maybe Guam or Puerto Rico or the Marshall Islands, or name your territory, or outside of the U.S.? Let's see, where are you located? Most of you are east of the Mississippi. Nobody west, huh? Too early in the morning maybe for the westerly people. All right. So it's really amazing, but 100% of you and 84% of you weighed in, and 100% of those are east of the Mississippi. So very interesting. Well, thank you for that. And now on to a more businessy kind of question. Curious if you're using OpenShift in your enterprise. And you might not know, and that's okay. Just click I'm not sure. You might know, and it might be, yes, I'm using it, but it's not on System Z. Or, yeah, I am using it, and by the way, I'm doing it on Z. Or we're not using it at all. And let's see, I'm getting responses all over the place. Looks like the majority of you are not using. And those of you who are using, but not on Z. One or two that are using on Z. And some of you that just aren't sure, and that's fine. All right, that helps us. That helps us to know what we've got. So yeah, that's pretty much where it's settled. Most of you know, but some, but not on Z. Great, thank you so much for that. All right, and then so now with that, I am going to stop talking and hand this over to Andy, who is going to take us through today's discussion. So Andy, this is all yours.
All right, thank you. All right, so good afternoon, everybody. Today we're going to talk a little bit about RedHat OpenShift and what you can do with it on IBM Z. And let's go ahead and get started. So when we're talking about OpenShift, OpenShift is a containerized orchestration platform that helps you to manage large containerized environments. So applications that you write for the cloud, write for containers, RedHat OpenShift gives you that orchestration layer. And that's very important because it flows into what's important with a lot of businesses today around being able to, modernize their application and their application development processes, as well as being able to, once you have those containers built or once those applications are built in a hybrid cloud environment, it allows you to run your applications where they most make sense to run. So this is very important to a lot of businesses. It's, it's high on the agenda with most people. And OpenShift underpins a lot of the hybrid cloud and application modernization movement. When we're talking about, utilizing OpenShift, especially on IBM Z, we see some common patterns emerging around, modernization. Like I said, about being able to develop new types of applications, cloud native applications where they're developed for the cloud. So containerized, and then being able to take advantage of, the IBM Z capabilities, such as being able to co-locate workloads. So think about, you have these new containerized workloads that may sit next to your ZOS workloads. This allows you to, have very low latency connectivity between those two environments. And that goes to, more of the integration. So again, being able to integrate between your existing workloads such as ZOS and even LinuxONE. And you also pick up a lot of the platform capabilities that come with the Z. So think, highly scalable, very resilient. You've got different things like cryptographic hardware that you can take advantage of, high throughput. You can take advantage of things like on the Z16, the Telum processor to do AI inference and stuff like that. So there's a lot of different capabilities that you get when you run OpenShift on Z. And throughout this presentation, you'll hear me mention IBM Z and LinuxONE. They're basically the same boxes. One you run Linux only workloads on, the other one you can run ZOS and Linux workloads on. So I'll probably just refer to everything as IBM Z going forward. Some of the reasons you might want to think about running workloads on Z or LinuxONE is the ability to take advantage, like I said, of the, for example, like the cryptographic processors, the cryptographic express cards, giving you the ability to, do a lot of offloading of cryptographic functions and various things like that. You've also got very robust multi-tenancy abilities. So, each LPAR in an IBM Z or LinuxONE is considered a separate, completely separate server, air-gapped server. Even within the, virtual machines running under KVM and VM, you have isolation and separation so that you can run multiple, different, for instance, different companies on the same box or different departments on the same box. So those workloads won't interfere with each other. You gain the, scalability characteristics of IBM Z. You can run thousands of containers and virtual machines on an IBM Z platform. They can be designed and engineered to, run multiple IBM Zs to, in multiple locations for high availability and various other things. You've got the ability to do things like, add resources on the fly without having to take, downtime, for example, processors or memory or stuff like that. You have the benefit of being able to, be very tightly coupled with, ZOS applications. For example, if you're running on the same IBM Z box as ZOS, you can gain very low latency between those two workloads. You get the, advantage of being able to develop your containerized workloads just like you would develop them and maintain them on other platforms. So running OpenShift across platforms, you'll get a common interface. The development process will be, similar. So it allows you to, take advantage of a common environment. You also pick up, all the different RAS capabilities of IBM Z. You can architect IBM Z to give you, 7 nines availability with multiple IBM Z boxes and some other products. But again, you can develop these platforms to be very highly available. And then a lot of cases you will be able to pick up from existing operational efficiencies. So, these environments can flow into your existing backup and recovery, high availability DR strategies, just like your other Z workloads. When we're, IBM provides several different containerized technologies or ways to run containers. So we'll go from left to right here. We're going to concentrate mostly on the two to the right here, but from a ZOS standpoint, you have, this is fairly new, you've got a ZOS container platform, which basically is designed to run, ZOS Unix type applications as containers that require, low latency sitting right inside ZOS. So they're running native on ZOS. And then you've got to run Linux-based containers. This has been around for a while. So you've got the first iteration of the IBM Z container extensions brought you the ability to run, Docker type containers. So not a lot of orchestration, but a lot of, application specific or specific appliance type applications that needed to be tightly coupled with ZOS. And then the two that we're going to concentrate on today are the ability to run the OpenShift directly under ZOS or on Linux workloads running on Z. So the Z container extensions give you the ability to run OpenShift. It runs just like another address space under ZOS. It takes advantage of specialty engines, so zip engines in this case. So you're not adding to your general purpose engines their workload. And then you have the ability to actually run, if you were going to stand up a Linux environment, say, for example, in another LPAR under ZVM or KVM. This allows you to deploy, even on a Linux-only box or Linux-1 box, and can take advantage of, a lot of the characteristics of the IBM Z. And these run on IFLs, which is another specialty engine, and it doesn't impact your, ZOS workloads. Two main choices that you have for running OpenShift on IBM Z is if, you have to decide where you're going to run it, whether you run it under ZOS or whether you run it under, a Linux infrastructure. There's, benefits to either. It really depends on what your needs are. So if you're running it under ZOS, you can, your ZOS systems programmer can install OpenShift. It installs just like any other middleware type application on ZOS. They don't have to know a lot about OpenShift. It's just another application. When you're running it under ZOS, it inherits all those quality of service characteristics. So workload manager and all your DR and all your backup and recovery, all that that all fits in there very nicely without having to make a lot of major changes. And this has been available since ZOS 2.4. If you're looking at standing up a Linux environment, so this would be standing up on a LinuxONE or even on an IBM Z and another LPAR, other LPARs, where you are taking advantage of IFLs, so you can run, things like ZVM or KVM to virtualize these servers. And this gives you the ability to, scale and other capabilities. So what exactly is, when we're talking about OpenShift, to kind of give a level set here, a high, just a high overview, OpenShift is based on Kubernetes. So it's built on Kubernetes, which is the orchestration platform. It's an open source orchestration platform. And what OpenShift gives you is it gives you an enterprise version of Kubernetes. So with RedHat OpenShift, you get a very robust operating system underneath, in this case CoreOS. You get Kubernetes on top, and then on top of Kubernetes, you get all of the different functions and services that you need to actually run this environment. So where you would, in a Kubernetes environment, you would have to build a lot of these different services on top of Kubernetes. With OpenShift, all this comes pre-built, pre-integrated, pre-tested, and it's designed to work very well together. So it's kind of, once you get OpenShift up and running, you've got a, pretty much a complete environment. As your environment grows a little bit, there's services and stuff that comes with OpenShift, but there's additional add-ons you can get as your environments grow. So you can look at things like advanced cluster management, so you can, manage multiple OpenShift clusters. You can look at things like enhanced cluster security, so container vulnerability management, threat detection and response, and then you've got access to a global registry. If you want to do things like scan your images and have something that is highly available across your multiple OpenShift clusters. Underlying all of this is a version of, it's Red Hat Enterprise Linux Core OS, which is a, I think of it as a specialized version of Red Hat Enterprise Linux. It's been designed specifically to run containers, so it's optimized to run containers. And you don't have to worry about, having another distribution licensed to run OpenShift. It comes with OpenShift. So you don't have, and it's kept up to date. So as OpenShift progresses with functions and stuff, the underlying operating system also progresses and advances. I think, in fact, this chart might be a little out of date, but the point is that you get a complete package. So all the way from the operating system all the way up through all the management and other services with OpenShift. This is kind of a picture of what it might look like in a hybrid cloud or a multi-cloud environment where you are running OpenShift as your orchestration and container platform, so that you can run it wherever you want. You could run it under ZOS, you can run it under LinuxONE, multiple different methods. You can run, OpenShift runs on x86 and Power, and also out in the public cloud. So when you develop containers, to run on OpenShift, you can, it's the same platform across all these different hardware environments. This is kind of an example of, when we were talking about co-location and, kind of the capabilities that you have and the reasons you might want to run OpenShift on Z. You have the ability to have LPARs, right next to each other, running on the same box, so you can take advantage of very low latency connections. And you can scale, these environments as needed. And you can replace the, this middle box here is ZOS centric. You could replace that with, another traditional Linux workloads, for example, large Oracle databases or, web server farms, whatever. But the point is that you can have everything, tightly coupled and in one box or in multiple boxes. When we're talking about the, the development environment, DevOps and operations, the advantage to OpenShift is it gives you a common, or can give you a common method to, deploy applications, develop applications, and manage them. So with OpenShift, you get things like, self-service provisioning, consistent environments, automated build and deploys, you get configuration management, and this is, true across different platforms. So your different departments or organizations within your company, can kind of centralize or standardize on the way they deploy, new applications or cloud-ready applications. This is a kind of just a picture of what this might look like, and obviously there's other options here. This is just one set of options, but basically, you can have developers that develop on, utilizing like OpenShift dev spaces and things like VS Code and things that a lot of the newer application development people are used to. And, this can flow across, different things, as well as, being able to, you know, when we're talking about application modernization, you know, you can utilize different different components so that you can, you know, modernize some ZOS applications or pieces of ZOS applications. There's many different things you can do with this. Again, this is kind of what this would look like. You know, the different ways you can deploy OpenShift. Commonly, you know, it's deployed usually in virtual machines, either under VM or KVM. A newer capability is to deploy OpenShift on bare LPAR, so you don't need a hypervisor. It would obviously require multiple LPARs, but so it eliminates the need for that hypervisor. And then over on the right, you have the ZCX, the container extensions. And at this point, Maria, if there's any questions, I can pause and answer those.
Perfect. Yes, we do actually have a question. And this is interesting. So, Richard, thanks for asking this. Richard is asking if you're looking to replace VMware for non-containerized workloads, how does OpenShift compare with OpenStack? Could you comment on that, Andy?
Well, okay, so OpenStack and OpenShift are kind of different as far as, you know, I think of OpenStack as, you know, more of an infrastructure layer where it allows you to, you know, deploy underlying servers and, you know, Linux servers and other types of servers, whereas OpenShift is more geared towards actually deploying, you know, containers. But having said that, you can, you know, OpenShift on X and other platforms, you can use OpenShift to deploy virtual machines, which is something that, you know, is being looked at heavily today as far as, you know, replacing VMware or whatever. But you can run, you know, just instead of, you know, just pure containers, you can utilize OpenShift to deploy virtual machines. So with standard workloads within those virtual machines. So I hope that answered the question.
Yeah, thanks. Thank you, Andy. And thanks, Richard. And I also, James Marcinek, who is one of our RedHat business development individuals that's here on in the background, just sent me a link to a RedHat article that addresses this as well. So I am going to throw that in the chat. Thanks, James, for being there and for that. So, Richard, go ahead and pick that up if you want off the chat. That might also be helpful. Okay.
All right.
Thank you. All right, Andy.
All right, I'll go ahead and continue here. So next section here, we'll kind of talk about the different ways to actually implement OpenShift on Z. So the picture here is for if you're going to deploy it under VM, but we'll talk a little bit about the myriad of different ways you can deploy OpenShift on Z. From a ZOS standpoint, there's, you know, you use ZOS management facility to deploy OpenShift just like you would any other ZOS product. So it's very, very self-contained and very easy to deploy on a ZOS system. The person deploying it really doesn't have to know a lot about, you know, OpenShift, the internals of OpenShift. It's just another application that they're deploying. If you're talking about deploying OpenShift on a Linux-based servers, there are several different ways to do this. You know, originally, OpenShift on Z is what's considered to be a user-provisioned infrastructure. So that means you get to build all of the different Linux servers that host your control planes and your compute nodes and various other components of OpenShift. And that can be done manually. That can also be done utilizing things like Ansible. you can use another option, especially for VM. IBM has a enhanced system installation product that basically allows you to, as you're deploying ZVM on IBM Z, you can also deploy OpenShift in the same process. So that's a very easy way to get up and running quickly without having to, build all the customized installation files and everything. So it's a quick and easy way to, get something up and running. This slide here shows another method where you can utilize something like a cloud infrastructure center, which helps you build all of those underlying Linux servers that host the control planes and the compute nodes, and also that can also be automated through Ansible as well. So there's various different ways to implement this, and as we move forward here, there's a couple newer ones that have come out recently. When you're implementing OpenShift, there's a lot of configuration that you have to do for your environment, so networking and various other things, and those configurations can be, fairly in depth. But with products like the assisted installer, what this allows you to do is you'll log into a RedHat website, and it will help you build that configuration. It will also verify the configuration, and then will build what you need to actually deploy this on your IBM system. You can also automate this with REST APIs. The agent-based installer is pretty much the same thing as the assisted installer, but it helps you to deploy OpenShift in more of a disconnected environment, so you're not so where you wouldn't have direct access to different pieces that are needed to actually build OpenShift from the internet. Talk a little bit about the different capabilities that IBM Z brings to OpenShift. You've got, I've mentioned this before, but with the right hardware and software, you can build very resilient, highly available OpenShift clusters. So you can get you can get 7 nines availability using utilizing things like Hyperswap and GDPS for IBM Z. You can take advantage of the, your containers can take advantage of the Crypto Express cards. So if you have a lot of, heavily, a lot of applications that require a lot of cryptography, then you can certainly utilize the Crypto Express cards from within your applications. One of the other features that you can take advantage of that's on IBM Z is the ability to use secure execution, which is an extra layer of security. It basically separates those KVM virtual machines from the actual host, so the host can't get to them, can't see what's going on inside as far as to help protect you against mistakes or bad actors, but it also helps protect against other virtual machines running under KVM that are running your OpenShift workloads. So kind of gives you an extra layer of protection for multi-tenancy and also other security threats. Let's talk a little bit about what you can do with, OpenShift requires by itself, the platform requires disk storage, as well as, most of your containers, depending on what they are and how they're written, are going to require persistent storage. And there's a myriad of different ways to accomplish this on Z. You can do it manually, which is, fine for, 1 or 2 containers. But when you start to scale, you need something like a software-defined storage implementation. And the Storage Fusion data foundations or OpenShift data foundations are the same thing. Gives you the ability to abstract the underlying disk storage from the OpenShift operations, so that your people can simply request a certain amount of persistent storage or whatever, and they don't have to worry about whether it's what kind of physical storage it's sitting on in the back end. And it's very easy to, we'll talk about operators in a minute, but it's fairly, it's tightly coupled with OpenShift, and it's easy to deploy. And it supports the 3 major classes that you would run into for these workloads. So S3 object, block, and file storage. Another option, if you need to really scale, very large environments and you need parallel data access, is the IBM Storage Scale solution for data and AI. So this gives you additional capabilities beyond what Data Foundation can do for different types of workloads. And then there's a IBM Storage Fusion, which is a combination of these 2 technologies, and you can utilize them in differing degrees. They don't have, you can mix and match depending on what your needs are, but this is for very highly scalable, large environments, and it gives you a lot of backup and recovery availability and stuff like that. So there's a lot of different options that you can use, but a lot of them make it easier to administer OpenShift in your applications. Talk a little bit about some of the newer things that came out with the newer versions of OpenShift. We've got things like multi-architectural compute. We've got, I mentioned before, like LPAR support and the agent and assisted installers, as well as a single node OpenShift. So we'll talk a little bit about those. This is a picture of what it might look like for a multi-architectural environment where you have a OpenShift cluster that is managed from IBM Z or LinuxONE. You've got your control planes and some compute nodes out there on IBM Z, but you can also add additional compute nodes out on x86. So within OpenShift, you have the ability to create containers that are multi-architectural. So when you create these containers, you can create basically 2 different versions of that container. So depending on where it gets deployed, it can be created to run on x86, or it can be created to run on IBM Z, which is the S390X architecture. You can also do the opposite. So you can flip this around, and you could have an x86 OpenShift cluster that had the control planes and some compute nodes. And then if you wanted to, you could add additional compute nodes to an IBM Z, for instance, for scalability or whatever, that you can manage all from one OpenShift cluster. The single node OpenShift cluster, in the past, when, in order to deploy OpenShift, you basically had a minimum configuration, where you were looking at, at least 3 different nodes of 3 LPARs or 3, large virtual machines. It can be any combination of, a myriad of different things. But now you have the ability, for instance, if you wanted to, just get something up and running and to do some, development or to see how things worked, you have the ability to deploy this in a single node, so just 1 LPAR. This allows you, it consumes less resources. You don't have to have as much storage. You don't have to have as many IFLs or zips for processors. Good for, test environments and very small OpenShift environments. The thing that you lose with this, though, OpenShift is designed to be highly available. So, you always have multiple control nodes, multiple compute nodes, so you don't have single points of failure. This kind of eliminates that, but like I said, it's a good place to maybe start testing or for a small development environment. Talk a little bit about operators. Operators in OpenShift are kind of prepackaged solutions, very easy to implement. You don't have to do a lot of configuration. You don't have to build a lot of different things. They're pretty much point and click. The OpenShift data foundations talked about the software or the storage solution. That's an operator. There's a couple more here that might be of interest to you. So there's tons of operators out there available, and there's new ones being added all the time. But basically things like compliance operator, which can help you, with your regulatory readiness for different regulations and requirements that you have to go through to make sure that your environment is secure and compliant. And then along with that, you have things like a network observability operator, which allows you to it's an enhanced way to be able to see your network and do troubleshooting, and helps you with security of your OpenShift cluster. Realize that there was a lot of information there, but I'm going to sum up here. This is my last slide. So when we're talking about OpenShift on Z, you have quite a few different options on how you want to run it. You can take advantage of a lot of the capabilities that IBM Z and LinuxONE provide kind of out of the box. And there are many different ways to implement it. It gives you the ability to run the same type of environment across platforms and run your containerized workloads where they make sense. So at this point, Marie, I'll stop, and if there's any questions, I'll answer those.
Thank you, Andy. That was awesome. Let's see, we do have a question, and Bob is asking, what is required? You mentioned IFLs, you mentioned zips, you mentioned maybe some other resources. What is required to deploy a cluster on Z?
So traditionally, OpenShift, you'd require at least 3 to be, highly available, or, you would require, 3 LPARs. Within those LPARs, you would require, 6 IFLs if we're talking about Linux. You've got several, probably up to 7 virtual machines that you have to create initially to get, you've got 3 control nodes, 2 compute nodes, and some Bastion server and Bootstrap server and those type of things. You need access to OSA or Rocky cards for communications. You're going to need a minimum of probably 1 terabyte of disk storage per cluster. Plus, you're going to need additional storage for things like, image repositories and anything that requires persistent storage. And then as far as the memory goes, spread across those 3 or more IFLs or 3 or more LPARs, you're going to need probably, at least 100 gigabytes of memory. Now with the single node option, that cuts that down, so kind of cut that by 2/3, so you can stand something up like within 2 IFLs or 2 zips, and the the number of control planes and compute nodes are reduced. You'll still need access, obviously, to your OSA and Rocky cards communications, but your disk storage will be reduced, as well as your memory requirements.
Okay, so suffice it to say, there are some resources that are required
yes,
before you embark on that.
This is not a small, implementation. So this does require some real resources. So.
Okay, great. Thank you. And thanks for that question, Bob. The other thing that I wanted to do too, while I had a quick moment here, because there was so much discussion earlier about comparing OpenShift to VMware, to OpenStack, I'm assuming that there's a lot of interest, and we're hearing it all the time from our customers about alternatives to VMware. Or, do I stick with what I have? What's the risk of changing and moving? What are the alternatives, and so on and so forth? And I was kind of hearing that through this discussion a little bit here. So I'm going to chat out a video that we have up on our site that was created for that purpose, to kind of talk about, what we're seeing and what the approach we're suggesting should be if you're going to look at making a change and that type of thing. So I just chatted that out. When you have a second, it's a short video, it's a few minutes. Take a peek at that. That might help to answer a bunch of questions, or at least give you what Mainline's perspective is, and what we think customers should be looking at and doing at this point in time with all of that whirling around with the Broadcom acquisition. So wanted to share that. All right, I don't have any other questions currently in the chat. You're welcome, Eric. With that, unless there's anything else that pops in here in the next 30 seconds or so, I think we can call this a wrap. Please be aware that we are here to help. Andy's here to help. If you have a Mainline account executive, please reach out to them, or you can always go to mainline.com, hit the contact us. That'll come to me, and be happy to take any requests that way as well. All right, so with that, we'll call it a wrap. Thank you all for your attention today. We appreciate it, and we look forward to seeing you all again here soon. So thanks, everybody. Have a good day and a great rest of the week.
All right, thanks, guys.